Okay, in this lab, we're going to implement a simple logic function. And so I wanted to walk you through an even simpler example of the steps that you would need to take to breadboard a simple logic function. So the logic function we're going to do is f is equal to a bar ANDed with b, ORed with c ANDed with d bar. So as you look at that, I have the AND operation that you see twice. I have an OR operation, and then I have two inversions where I need to take A and come up with a bar. So there's three chips that we're going to need to implement this directly onto a breadboard. All right, so the first one that I'm showing here, and you can Google these from the internet, look for inverters, and it turns out that a common numbering that is used for an inverter chip is a 7404. All right, and so you download the schematic for that, and it says hex inverter, and so it's funny where the terms come from, but in this case, hex literally means 6, as opposed to hexadecimal that we've been talking about in class, where we're talking about base 16. But often hex is used to refer to hexadecimal, so there's some ambiguity there. In this case, hex means that there's 6 inverters on this chip. All right, and so on the digital trainer video, we talked about you have to power up each of the chips, and so that involves connecting it to VCC and to ground. And in this case, all 3 of these chips use pins 14 and 7 for the power. All right, so you have to do that. Also in the diagram, there's a notch that shows when you look at the physical chips, you can usually see a notch on the chip that helps you orient that correctly on the breadboard. Okay, so let's move on from there. What you're going to need before you ever get started is a wiring diagram. Okay, so it'd be tempting with this simple circuit to just jump in there and get started, but I'm telling you, it'll save you work in the long run, even for a simple circuit, to have a schematic diagram that you can use to help figure out how you're going to breadboard this. Okay, so we're going to start with putting the AND gates down, followed by the OR gates. So let's configure the gates. But I also know that I'm going to need an inversion for A. I don't need an inversion for B or C, but I need an inversion for D. Okay, and so this is A, B, C, and D, and we're going to connect those with switches. Okay, so I think these switches are labeled. Let me go back up in here. Yeah, I'm going to use switches 3 through 0 right here. All right. Okay, so back to my schematic. Let's go SW3 is A, and SW2 is B, SW1 is C, and SW0 is D. All right, so we can figure out what's controlling our variables, and we have our schematic for the logic functions, and then we know that these connect to the LEDs, and I think those are probably labeled as well. Not as obvious, but you can use any one of those. So I'm going to call it LED 0. That's going to be our output. Okay, so along the way, we know that we have chips that we need to use, and for the inversion, we need the O4s. All right, it can be that if you have enough logic gates, you'll need more than one chip. All right, so it's common when you're making a schematic to label the chip number, like in this case, 04, and it's our first one. And in the digital tradition, we'll start at 0 for our numbering. We only have one chip that we need, so we don't have to ever go to 04-1 for any of the chips on this circuit. But my point is, you label what the chip number is, and the AND gates are 08s, and the OR is a 7432. All right, from there, I look at my pinouts and I see, okay, 1 is an input and 2 is an output. So for the first connection, I can label 1 and 2. But then that gate, I've used it, okay? I can't reuse it in a different spot. I need to use different pin numbers, okay? And so 3 and 4 would work for the other inverter, because looking at the schematic, 3 is the input, 4 is the output. All right, so you see my point. You're trying to figure out the pin numbers, and you need to label those on your diagram so you can get the connections right when you hook it all up. Okay, so the next thing is, let's look at the AND gates. And so I see pin 1 is an input, pin 2 is an output, an input, and pin 3 is the output. Okay, then the next one I can use, I'm going to use, the next obvious one would be 4, 5 with 6 as the output. I'm going to use these 3 because I can, all right? So I'm going to go with 10 as an input, 9 as an input, and then 8 as the output. All right, and then on the 7432, I can use pins 1, 2, and 3. I can use different pins just as long as I get the inputs and the outputs straight. Okay, 1, 2, and 3. All right, so this is the diagram I need to see. A similar diagram is what I need to see before you start wiring anything up in the lab. So once I have the schematic diagram, I'm ready to do the connections to the breadboard. So my first step is, as we talked about before, make the power strip buses. Okay, so I would take a wire and I connect this to the plus 5 volt pin on the digital trainer. And then I'd be sure to jumper this across to make sure that power strip goes all the way across. All right, and I would probably make the lower half of, the ground bus go down here just because of the location of the chips. Okay, so make this connection to ground on the digital trainer, and again, do the jumper. All right, so next, we have switch 3 that's going to be controlling A, switch 2 is going to control B, and so forth down to switch D. All right, so what I would do is, you notice there's only 2 connection points on each of the switches, and I'd like to have the flexibility to have more of those, and so my practice would be to take a wire and connect it to some point on the proto board, probably the lower pin here. Let me try that again. Any point along here, and then I have these upper 4 as connection points to A. These are still connected to A, so it just gives me a little more flexibility, and I can use shorter wires and things don't look quite as messy. All right, so let's do that for all the variables. It didn't matter exactly which hole I hit, just I spread them apart so I have a little room to put the wires in. Okay, so that's that. And next, what I need to do is start putting the chips on the board and wiring up the power and ground on the chips. All right, so let me zoom in a little bit, and we'll just plop one down right here. And these chips, remember there were 14 pins, 7 in each direction. So 1, 2, 3, 4, 5, 6, 7. Let's call that the 04 chip, the inverter. Okay, and remember the pin numbering goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's the pin out. I need the same, I need to put in the AND gate as well. So 1, 2, 3, 4, 5, 6, 7. This is the 08. I'm not going to label the pins because we know the pattern. 1, 2, 3, 4, 5, 6, 7. And this is the 3, 2, the OR gate. All right, so what I need to do next is power these up, each of these chips. All right, so I could take a connection from pin 7 to the ground bus, pin 7. Come on, iPad. All right, pin 7 to the ground bus, pin 7 to the ground bus, and then pin 14 to the power bus for each of the chips. All right, so that's powering up the chips, and we're now ready to start doing the rest of the schematic diagram. So what I'm noticing is that the variable A goes to pin 1. Let me highlight that. The variable A goes to pin 1 on the 04 chip. All right, so I make that connection. All right, so remember variable A was right here with the switches. So I tap off A and I go to pin 1 using a wire and make that connection. All right, it's real natural to go to the very closest pin to the connection point, but you don't have to. It gives you a little more room if you give yourself some space to keep the wires spread apart. Okay, so that's one connection, and what I do is as I make these connections, I mark it off on the schematic diagram. All right, so from there, I know the output of the inverter is pin 2, and that needs to go to pin 1 of the 08 chip. Okay, so I take a wire, and I go from pin 2 to pin 1 of the 08. All right, so there's pin 1 on the 08, and I mark that off as being connected. All right. Then I have switch B going to pin 2. Switch B is right here. So I make this connection to pin 2. So at this point, I didn't have pin 2 connected. All right. We can do the same thing for C and D. All right. So C goes to pin 10. All right. And so I have this connection from C to pin 10 on the AND gate. So the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. So pin 10 is up here. And so I have a wire connection between these 2 points. Okay, once I have that, I mark that off. Okay, and I think you're getting the idea. If I wanted to connect this wire, I go to pin 8 on the 08, gets connected, pin 8 on the 08 gets connected to pin 2 on the 32. All right, so I look here and I take pin 8 and I make a wired connection to pin 2 over here. And then I can highlight that as being connected. So you see, that's why it's nice to have the diagram so you can systematically connect everything. By the time you've finished highlighting all the wires, everything should be connected. And you can do that with a little less mental stress about breadboarding. Okay, so I'm not going to finish the rest of that, but you would take the output, 3 is the output on the OR gate, the 32. And so this would be connected to this pin would be connected to the LEDs. So I think that gives you an idea of what you need to do. I'll give you a different logic function for the lab, but number one, you need the schematic before you even get started. And from there, you piece that together to get the logic function working.